Security is not just about response. It is about intelligent design that prevents the need for response. Welcome to CPP Module 5, Physical Security. And in this session, we begin Chapter 9, Structural Security Measures. This is one of the most concept-oriented and foundational chapters in the entire CPP syllabus. It forms the base of how we think about protection, not just reacting to threats, but designing systems that resist, delay, and deter them from the start. As we move forward, focus on understanding the logic behind structures, because in physical security, every wall, every door, every barrier tells a story of protection. In physical security, three major components work together: structural security, electronic systems, and the human element. This chapter focuses on structural security, the first and most permanent layer of defense. We will explore how buildings, barriers, containers, locks, and even lighting contribute to protection. These are not just passive elements, they're strategically designed to delay intrusion and buy critical response time. Remember, a well-designed structure can often prevent an incident before it even begins. Physical security stands on three pillars. First, structural security, the physical barriers like walls, fences, doors, and locks that create the foundation of protection. Second, electronic security, surveillance systems, intrusion detection, and alarms that monitor and alert. Third, the human element, the people who interpret signals, respond to threats, and make decisions. In this chapter, our focus is on structural security, because without a strong physical base, even the best technology or personnel cannot compensate for weak infrastructure. A barrier, whether natural or man-made, is essentially designed to control movement and restrict access. And that is where security truly begins. Barriers are the first line of defense in any security system. These include walls, floors, ceilings, roofs, doors, and windows, the core structural elements of any building. Their purpose is simple yet powerful: to delay, deter, and define access. A strong barrier does not necessarily stop an attacker permanently, but it buys time, and in security, time is everything. Understanding how these elements function and how they can be strengthened is essential for designing an effective physical security strategy. Walls are one of the most critical structural components in security. They can be made from materials like reinforced concrete, brick, stone, or wood, each offering different levels of strength and resistance. From a security perspective, walls must be evaluated based on their resistance to penetration, durability, and construction quality. Reinforced concrete walls, for example, provide high resistance and are difficult to breach, while lighter materials may be easier to penetrate. The key consideration is not just thickness, but also material strength, reinforcement, and design, because a wall is only as strong as its weakest point. Doors are often considered the weakest link in structural security. No matter how strong the surrounding walls are, an inadequately secured door can compromise the entire system. Different types of doors offer varying levels of protection, from standard industrial doors to bullet-resistant and blast-resistant doors designed for high-security environments. Vault and secure access doors are specifically engineered to resist forced entry and delay attackers. The key takeaway is this: a door must not just provide access, but also resist unauthorized entry effectively with strong materials, proper locking systems, and reinforced frames. While doors provide access, they also present some of the most common vulnerabilities in physical security. Standard locks can be picked in under a minute. Key knob locks can be bypassed quickly. And even hinges or louvers can be penetrated with basic hand tools. Panic bars, too, can be defeated with minimal effort. This clearly shows that attackers often exploit weak points rather than strong barriers. To counter this, upgrades are essential. Eliminate unnecessary openings, reinforce doors with steel plates, and use heavy-duty hinges. Installing high-security, multiple deadbolt systems, and ensuring proper door frame anchoring significantly improves resistance. The objective is simple: increase delay time and reduce easy access opportunities. Windows and other openings are necessary for functionality, but they also create potential entry points. Different types of glass offer different levels of protection. Annealed or plate glass breaks easily. Tempered glass is stronger but still vulnerable. Laminated glass holds together when shattered. and bullet-resistant glass provides the highest level of protection. Each option represents a trade-off between cost, functionality, and security. The key is to select the appropriate material based on the threat environment, ensuring that windows do not become the weakest link in an otherwise secure structure. To strengthen windows and openings, additional protective measures are often required. Window bars can physically block entry. Fragment retention films prevent shattering hazards, and blast curtains offer protection against explosions. Security shutters provide both physical and visual barriers, while proper design considerations such as limiting window size or using reinforced materials further enhance resistance. Other openings, such as vents or utility ducts, must not be overlooked. These are often unattended and can be exploited if not secured. In structural security, even the smallest opening must be accounted for because attackers will always look for the easiest path. Roofs and floors are often overlooked, but they play a critical role in overall structural security. Roofs can be vulnerable if not properly reinforced, especially against forced entry from above. Techniques such as embedding screens, using reinforced materials, and adding fasteners can improve resistance. Below-roofline barriers can create confined spaces that slow down intruders attempting to penetrate from the top. Similarly, floors, especially those below grade, must be designed to resist penetration. Earth covering and reinforced construction increase resistance and delay. The key takeaway is that security is three-dimensional. Threats can come from above, below, or through. Fencing and perimeter walls form the outer boundary of protection, the first visible layer of defense. They serve multiple purposes, defining property limits, deterring intrusion, delaying attackers, and providing a psychological barrier. While they may not completely stop a determined adversary, they create an important delay and signal that the area is protected. Effective perimeter design is not just about height or material, but also visibility, maintenance, and integration with surveillance and response systems. A well-designed perimeter sets the tone for the entire security posture. Chain link fencing is one of the most commonly used perimeter solutions due to its affordability and visibility. It allows clear observation on both sides, helping security personnel detect intrusions early. However, it provides only minimal resistance against determined attackers. Its effectiveness depends heavily on proper installation, adequate height, strong anchoring of posts, secure fabric fastening, and clear boundary marking. While it may not be the strongest barrier, when combined with other measures like surveillance and access control, it becomes an effective part of a layered security system. In physical security, no single element works alone. Strength lies in integration. Understanding installation details is critical to evaluating the effectiveness of chain link fencing. A typical installation includes components such as line posts, terminal posts, top rails, and the chain link fabric itself. Barbed wire is often added as a top guard to enhance security. Posts are usually embedded in concrete to ensure stability, with proper depth and spacing maintained between them. Each component plays a role, from maintaining structural integrity to resisting tampering. A poorly installed fence, even with good materials, can fail easily, which is why installation quality is as important as design. Fence top treatments and gates significantly influence the effectiveness of perimeter security. Top guards, such as barbed wire angled outward or inward, increase deterrence and make climbing more difficult. The direction of the angle often depends on the expected threat. Gates must be carefully designed, not just for access, but also for security. They should match the strength of the fence and include proper locking mechanisms. Turnstiles are used where controlled pedestrian access is required. They regulate entry flow and can be integrated with access control systems like cards or biometrics. The key is to ensure that access points do not become weak points. Beyond chain link, several other fencing types are used based on specific security needs. Cable systems are effective for vehicle control and can absorb impact before failure. Expanded metal or welded wire fencing offers greater strength and is more resistant to cutting. Wooden fences are generally used for low security applications and rely more on appearance than resistance. Electric security fencing, on the other hand, provides an active deterrent, delivering shocks and triggering alarms when tampered with. Each type serves a purpose, and selection depends on the level of threat, cost, and operational requirements. Decorative fencing combines aesthetics with basic security. These fences are often made of materials like steel, aluminum, or wrought iron, and are designed to enhance the visual appeal of a property. While they provide boundary definition and some level of deterrence, their primary function is not high security. However, modern designs may incorporate security enhancements such as pointed tops or integrated barriers. The key consideration here is balancing appearance with functionality, ensuring that security is not compromised for aesthetics. Cable fencing systems are designed primarily for vehicle control and perimeter reinforcement. They consist of steel cables connected between posts, often anchored in concrete footings for strength and stability. These systems are effective in absorbing and distributing impact forces, making them suitable for areas where vehicle intrusion is a concern. The structural design, including post spacing, cable tension, and anchoring, determines the system's effectiveness. This is a good example of how engineering design directly contributes to security performance. Blocking barriers are specifically designed to control or prevent vehicle access. These can be classified into passive and active barriers. Passive barriers include fixed installations like bollards, planters, and reinforced structures designed to stop or redirect vehicles. Active barriers, such as gates, wedge barriers, and rising bollards, can be operated manually or electronically and are often integrated with access control systems. The objective is to counter vehicle-based threats, especially in high-security environments where forced entry by vehicles is a major risk. Effective vehicle control is a critical component of modern structural security. Bollards are widely used as effective vehicle barriers in physical security design. Their effectiveness depends on proper design and installation. Height is typically controlled to ensure visibility and effectiveness, while spacing is carefully maintained to prevent vehicle passage without restricting pedestrian movement. They must be deeply anchored and often reinforced to withstand impact forces. Bollards are commonly used in high-risk areas such as airports, government facilities, data centers, and public spaces. The key principle is simple. Properly designed bollards can stop or redirect vehicles, making them a critical component in countering vehicle-based threats. Retractable bollards provide flexibility by combining security with controlled access. These bollards can be raised or lowered as needed using hydraulic, pneumatic, or manual systems. They are particularly useful in areas where access needs to be regulated, such as entry points for authorized vehicles. However, their effectiveness depends not only on design, but also on operation and maintenance. Regular inspection, proper training, and adherence to standard operating procedures are essential to ensure reliability. In security systems, even advanced solutions are only as effective as their maintenance. Combining bollards with fencing creates a layered security approach. While fences provide boundary definition and delay, bollards add strong vehicle resistance at critical. This integration ensures that both pedestrian and vehicle threats are addressed simultaneously. Additionally, modern systems may incorporate lighting, sensors, and other technologies, enhancing both functionality and appearance. The concept here is integration, combining multiple elements to create a stronger, more resilient security system. To evaluate the effectiveness of vehicle barriers, standardized protection ratings are used. These ratings are based on factors such as vehicle weight, speed, and penetration distance. For example, Department of State ratings and ASTM standards classify barriers based on their ability to stop vehicles under controlled test conditions. Higher ratings indicate greater stopping capability against faster and heavier vehicles. Understanding these ratings is essential for selecting the right barrier for a specific threat environment. Because in security design, decisions must be based on measurable performance, not assumptions. Wedge barriers are active vehicle control systems designed for high-security applications. They consist of metal plates installed in the roadway that can be raised or lowered as needed. Rising wedge barriers provide strong resistance and are typically operated hydraulically, allowing rapid deployment. Mobile wedge barriers offer flexibility and can be repositioned based on operational needs. These systems are particularly effective at controlling vehicle access at entry points and preventing forced entry. Their strength lies in rapid response and high stopping power. Proper installation is critical to the effectiveness of rising wedge barriers. These systems require strong foundations, typically embedded into the roadway with adequate depth to withstand impact forces. Key components include the front panel, crash arresting mechanisms, hydraulic cylinders, and drainage systems. The angle and height of deployment are carefully designed to maximize stopping capability. A poorly installed barrier can fail under stress, which is why engineering precision and adherence to standards are essential. This reinforces a key principle of structural security. Design, installation, and maintenance must work together to ensure effectiveness. Planters and jersey barriers are practical examples of combining functionality with security. Custom planters, available in various shapes and materials like steel or concrete, can act as effective vehicle barriers while blending into the environment. Planters with core barriers go a step further, integrating internal reinforcement to enhance stopping power without compromising appearance. Jersey barriers, originally designed for traffic control, are highly effective in redirecting vehicles due to their shape and mass. These solutions highlight an important concept: security measures can be both effective and inobtrusive when designed thoughtfully. Not all barriers are physical or mechanical. Some are symbolic or natural. Symbolic barriers use design elements like changes in flooring, landscaping, or visual cues to subtly control movement and discourage unauthorized access. Natural barriers, such as trees, shrubs, or water features, provide both security and aesthetic value. They blend into the environment while still influencing movement and access. These barriers may not stop a determined attacker, but they play a key role in guiding behavior and supporting layered security strategies. Containers, safes, and vaults represent the innermost layer of physical security, protecting the asset itself. Their effectiveness depends on factors such as lock resistance, material strength, and construction quality. A container labeled as a safe does not automatically guarantee protection for all types of threats. Different assets require different levels of protection, and understanding the limitations of each type is essential. In structural security, protection becomes more focused and specialized as we move closer to the asset. Safes are designed for different purposes, primarily fire protection or burglary resistance. Fire-resistant safes are built to withstand high temperatures for specific durations, protecting documents and media from heat damage. Burglary-resistant safes, on the other hand, are designed to resist forced entry using tools or explosives. It is important to understand that a safe designed for fire protection may not provide strong burglary resistance, and vice versa. Therefore, when both risks exist, a combination approach must be used to ensure comprehensive protection. UL ratings provide standardized measures of a safe's resistance to burglary attempts. These ratings indicate the type of attack, the tools used, and the duration for which the safe can resist. For example, ratings may involve attacks using hand tools, power tools, or even explosives with increasing levels of resistance. It is important to note that these ratings do not represent the total time to break into a safe, but rather the net working time under test conditions. Understanding these ratings helps in selecting the appropriate safe based on threat level and asset value. Vaults provide the highest level of physical protection for valuable assets. Fire-resistive vaults are designed to withstand extreme temperatures, protecting contents from fire damage. Forced entry vaults focus on resisting physical attacks, using reinforced materials and advanced locking systems. Rebar sizing, construction techniques, and material strength all play a critical role in determining effectiveness. However, even the strongest vault can be compromised by poor operational practices. This highlights a recurring theme in security. Technology and structure must be supported by proper procedures and disciplined use. Locks are the most widely used method of controlling physical access. They secure the movable points in a structure, primarily doors and windows, and play a critical role in day-to-day security. However, locks should not be relied upon as the sole means of protection. They're most effective when integrated with other structural and electronic measures. Locks can be broadly classified into purely mechanical systems and those that combine mechanical and electrical components. Understanding how locks function and their limitations is essential for designing an effective access control system. There are several types of mechanical locks, each with different levels of security. Warded locks are among the oldest designs, simple but highly vulnerable to manipulation. Lever locks offer improved security and are commonly used in safes and secure storage. Pin tumbler locks are the most widely used today, offering better resistance through precision-engineered pins and key combinations. Dial combination locks eliminate the need for keys and provide controlled access through numeric combinations. Each type has its strengths and weaknesses, and selecting the right one depends on the level of security required. Master keying systems allow multiple levels of access using a hierarchy of keys. A single lock can be opened by different keys, enabling efficient access control in large organizations. This system is particularly useful where managing numerous individual keys would be impractical. However, it also introduces security risks. Loss or compromise of a master key can expose multiple locks, and additional shear lines in the lock can increase vulnerability to manipulation. Maintenance issues may also arise due to increased complexity. Therefore, while master keying offers convenience, it must be implemented with careful control and oversight. Electrified locking mechanisms combine mechanical strength with electronic control. Electric strikes allow doors to be remotely unlocked while maintaining a secure mechanical latch. Electromagnetic locks, or maglocks, provide strong holding force but require continuous power to remain locked. Exit devices, such as panic bars, enable quick and safe egress during emergencies. Wireless locks integrate with access control systems, allowing remote management and monitoring. These systems enhance flexibility and control, but also depend on reliable power and proper integration. A critical concept in locking systems is the difference between fail-safe and fail-secure. Fail-safe systems unlock when power is lost, ensuring safe exit during emergencies. These are commonly used on emergency exits. Fail-secure systems remain locked during power failure, maintaining security but requiring alternative exit provisions. The choice between the two depends on the balance between life safety and security requirements. Compliance with building and fire safety codes is essential when making this decision. Ultimately, the system must protect both people and assets. Designing an effective locking system requires a holistic approach. It is not enough to focus on the lock alone. The entire barrier must be assessed, including doors, frames, walls, and surrounding structures. Security must be designed into the system from the beginning, rather than added as an afterthought. Clear policies must define who has access, how keys are controlled, and how systems are maintained. Even the best hardware can fail if procedures are weak. The key takeaway is this: effective locking systems combine strong design, proper installation, and disciplined management. Lighting plays a critical role in physical security, not just for visibility, but as a deterrent to criminal activity. A well-lit environment discourages intruders, improves observation, and supports both human and electronic surveillance systems. Lighting enhances the effectiveness of CCTV, assists in response operations, and contributes to overall situational awareness. It serves three primary purposes: creating a psychological deterrent, enabling detection, and improving surveillance capability. In modern security design, lighting is not just illumination, it is a strategic tool. There are several types of lighting equipment used in security applications, each serving a specific purpose. Streetlights provide general area illumination with wide coverage. Floodlights are used for larger areas, such as perimeters and open spaces. Fresnel lights produce narrow, focused beams, useful for highlighting specific zones or detecting movement. Searchlights generate high-intensity beams for targeted illumination in specialized situations. High-mast lighting is used in large open areas like parking lots and highways, providing broad and uniform coverage. Selecting the right type depends on the area, threat level, and operational requirement. Different lamp types offer varying levels of efficiency, color rendering, and operational performance. Incandescent and halogen lamps provide excellent color rendering but are less energy efficient. Fluorescent and metal halide lamps offer improved efficiency and are commonly used in larger installations. High-pressure sodium lamps are highly efficient but have poor color rendering, making identification difficult. LEDs combine high efficiency, long life, and good color rendering, making them ideal for modern security applications. Understanding these characteristics helps in selecting the right lighting solution for both performance and cost effectiveness. LED technology has transformed security lighting. It offers instant start and restart, high energy efficiency, and long operational life. LEDs provide better control over illumination levels, reduce energy consumption, and support advanced features like dimming and smart control. From a security perspective, LEDs improve visibility and eliminate dark patches, enhancing detection and surveillance. The key lesson is that modern lighting is not just brighter, it is smarter, more efficient, and more adaptable. Lighting must be carefully balanced because both too little and too much light can create security problems. Insufficient lighting creates shadows and blind spots, making it easier for intruders to conceal themselves. Excessive lighting, on the other hand, can cause glare and reduce visibility, especially for cameras and observers. Light trespass, where light spills into unintended areas, can also create nuisance and operational issues. Effective lighting design ensures optimal illumination enough to detect and deter, but not so much that it hinders visibility. The direction of lighting is just as important as its intensity. Properly directed lighting ensures uniform coverage and eliminates dark spots. Poorly directed lighting can create shadows, glare, or uneven illumination, reducing overall effectiveness. Overlap between light sources is essential to maintain consistent visibility across the area. The objective is to illuminate the target area clearly without creating blind zones or visual discomfort. This reinforces a key principle: in security lighting, placement and direction are as important as brightness. To design effective security lighting, it is essential to understand key performance metrics. Lumens measure the total quantity of light emitted by source. Illuminance, measured in lux or foot candles, indicates how much light actually falls on a surface, which is critical for visibility and identification. Reflectance defines how much light is reflected from surfaces, directly affecting how objects and people are perceived. Color temperature, measured in Kelvin, influences clarity and recognition, with different ranges suited for different environments. These metrics form the foundation of lighting design and must be carefully balanced for optimal security performance. Security lighting must follow established standards based on application and risk level. Different areas, such as perimeters, parking lots, entrances, and critical infrastructure, require specific minimum lighting levels. These standards ensure adequate visibility for detection, identification, and response. For example, higher illumination is required in high-risk areas, while moderate levels may suffice for general zones. Adhering to these guidelines ensures consistency, effectiveness, and compliance with regulatory requirements. In security lighting, standards provide the baseline, but design must adapt to real-world conditions. Lighting plays a vital role in enhancing electronic surveillance systems. Proper illumination improves camera performance, especially in terms of image clarity and identification. Color cameras require higher light levels compared to monochrome cameras. White light is generally preferred for compatibility with surveillance systems, while infrared lighting is used where visible light is not feasible. Correct positioning of light sources is also critical to avoid glare and shadows that can degrade image quality. Ultimately, lighting and surveillance must work together as an integrated system. Economic factors are a key consideration in lighting design. Energy consumption typically accounts for the largest portion of cost, often as high as 80 to 90%. Capital costs, including equipment and installation, form a smaller portion, while maintenance adds to long-term expenses. Efficient technologies like LEDs significantly reduce energy and maintenance costs over time. Planned maintenance strategies, such as group lamp replacement, can further optimize costs. The goal is to achieve the right balance between performance and cost effectiveness without compromising security. As we conclude Chapter 9, let's revisit the key takeaways. Effective structural security is built on a balanced design integrating barriers, locks, lighting, and supporting systems. LED barriers increase delay and strengthen defense. Active systems require proper maintenance and operational discipline. Lighting is not just about brightness, but about quality, placement, and integration with surveillance. Above all, security is not achieved through a single measure, but through thoughtful design, integration, and continuous evaluation. Let me leave you with this thought. Security is not a product you install. It is a system you design, maintain, and constantly improve. Thank you for your time and attention. If you found this session useful, do subscribe and stay connected for more structured learning content.